Okay, looking at number 15 through 19, the first thing I'm going to notice about all of these triangles is that they're all right triangles. And when we are looking at right triangles, earlier in the semester, we learned two main things that we could do with these right triangles. This is from the earlier unit, where the first two things that we had learned were the Pythagorean theorem. And the Pythagorean theorem said that a leg squared plus another leg squared equaled the hypotenuse squared. And we also learned about our special right triangles. There were two of them. There was the 30, 60, 90-degree triangle. And we said that whatever was opposite the 30, we would call that x. Across from the 90 was double that, 2x. And across from the 60 was x root 3. We also learned about the other special right triangle, the isosceles right triangle, where both of the angles were 45 degrees, which meant that the sides across from them would be the same because it's an isosceles triangle, and the hypotenuse was always going to be that number times root 2. So when I'm doing these problems above, that's what I'm trying to use first. Later on in the year, we learned about trigonometry, and that might come up later in the packet. All right, so looking at number 15, it's a right triangle. I'm going to see the right triangle right there. And we are looking for one of the legs, and we know two of the other sides. If you know two sides in a right triangle, you must use the Pythagorean theorem. It's that a leg squared, well, x is a leg, plus the other leg squared, well, 7 is the other leg, and we know that they're legs because they make up that right angle, equals the hypotenuse squared, and the hypotenuse, that's always going to be the thing that's across, or the side that's across from the 90-degree angle. All right, we're just going to finish this up. X squared plus 7 squared is 49 equals 10 squared, which is 100. Subtract 49 from both sides. And that tells us that x squared is 51. And then to find x from that, we're going to take the square root of both sides, so x becomes root 51. If there's a perfect square that goes into 51 that you can think of, by all means try to divide it out so that we can simplify it, but I'm pretty sure that 51 is as simple as it can be. All right, for number 16, once again, we're looking at a right triangle. We know two of the sides. We don't know the hypotenuse, so since it's a right triangle, we can use that Pythagorean theorem. Leg squared, one of the legs is 4, plus the other leg squared, 7, equals the hypotenuse squared. The hypotenuse being across from the 90-degree angle, that's going to be x. 4 squared is 16. 7 squared is 49, equals x squared. If we add 16 and 49, we get 65. Let me just check with my calculator. 16 plus 49, yep. 16 plus 49 will be 65. And if I take the square root of both sides, I'm going to get that x is the square root of 65. Let's check to see whether that 65 can be simplified. I know 5 goes into it, but 5 goes into it 13 times. And since 5 and 13, you can't take the square root of either one of them. Root 65 is simplified as well. Moving on to number 17. It looks pretty complicated because we're looking for an x and a y, and there's two right triangles together, but we can just try and solve each one separately. So if I look at this big one on the bottom, it is a right triangle, but I don't know two of the sides, so I can't use the Pythagorean theorem on it. I also don't know any of the angles. And if we don't have the angles labeled, I don't want you to try to add them to the figure. Adding to the figure is never a good idea unless you're trying to solve for an angle, and we're not asked to. So let's start with this other triangle, also a right triangle. We know two of the sides are 4 and 3, and we're looking for the hypotenuse, the one that's opposite that 90-degree angle. Let me start with the Pythagorean theorem here. 4 squared plus 3 squared, both legs, equals y squared. 4 squared is 16. 3 squared is 9, y squared. 16 plus 9 is 25. And that tells us that y is actually 5, because the square root of 25 is 5. You might recognize that to be one of our special right triangles, which is the 3, 4, 5 right triangle. All right, moving on. Now that I know that side, now that all of a sudden this big triangle here, I know what one of the sides is, and now I have two sides, so I can use the Pythagorean theorem on that. The legs are now 12, and 5, so I'm going to square them, equals x squared. 12 squared is 144. 5 squared is 25. X squared. If I add 144 and 25, I get 169. And the square root of 169 is actually 13. So that has solved x and y. All right, moving on to number 18. So number 18 is automatically a little bit different to me, and I can see it because they've given me this angle, this 45-degree angle. And now that we know SOHCAHTOA and trigonometry, you are welcome to use that. It will definitely work for you. But we want you really to remember those special right triangles. In a special right triangle, we said that the sides opposite the 45-degree angles were both x, and then the side opposite the 90-degree angle we had referred to as x root 2. Now we're looking, and I know I just called this x, we're looking for this side. This is the side we're looking for, okay? So if 15 is x, this side is also 15, and opposite the 90-degree angle is simply 15 root 2, because the hypotenuse is root 2 times the side opposite the 45-degree angle. Okay, moving on, looking at number 19. This one's different as well because of this 60-degree angle. 60-degree angle informs me that it's a special right triangle. And we had labeled the sides opposite the 30-degree angle. We had labeled it x. It's already labeled x, thankfully. Opposite the 90-degree angle, we'd labeled this 2x. And opposite the 60-degree angle, we'd labeled that x root 3. Okay, so if opposite the 90, the one that we know both of them is this one right here, that 8 equals 2x. And if 8 equals 2x, if I divide both sides by 2, x will just equal 4. That tells us the side that's opposite the 30-degree angle. To get the side that's opposite the 60-degree angle, I have to take that x value, which we just said was 4, times it by root 3, and that will tell us y. And we're done.